Hi everybody. Today we're going to be working on a new lesson, working with constraints, system of linear inequalities. We have about two more after this, I want to say, and then we will be having our test. We're going to look at the warm-up. It says determine an order pair x, y that satisfies each inequality. So this could be anything that you guys come up with. I'm going to give you just some examples that I have. There's multiple answers to this. So it says x plus y is less than 18. So one problem I could say is x is 1, so you can write it in parentheses. X is 1, y is 2. 1 plus 2 gives you 3, so 3 is less than 18. Next, x minus y is greater than negative 7. So, once again, we're going to write it in the parentheses as x, y as our coordinates. The easy one I'm going to use is 0 and 0. 0 minus 0 gives you 0. 0 is still greater than negative 7. 2x plus 3y is less than or equal to negative 5. So a problem I'm going to do, let's see if this one works. 2 times negative 1 plus 3 times negative 1. So we know 2 times negative 1 is going to give us negative 2. Negative 3, or 3 times negative 1 is going to give us negative 3. Negative 2 plus negative 3 gives us negative 5. And we said this can equal to negative 5 as well. So negative 1 works. Negative 5x minus 2y is greater than or equal to 10. So what we could do is, let's try this one. Negative 5 times 0 minus 2 times, let's go 3. Let's see if this works. Okay. Negative 5 times 0 gives us 0. Negative 2 times 3 gives us negative 6. Negative 6 is not less than or equal to, or greater than or equal to 10, so we know that one does not work. Okay, so let's try a different number for that one. We'll leave the 0. Negative 2 times, let's try negative 5. Once again, that gives you 0. Negative 5 times 0. Negative 2 times negative 5 ends up giving you positive 10. Positive 10 is greater than or equal to 10, so that works. So we can put x is 0 and y is negative 5. As I said, there's various ways you can write ones on here. I could have done negative 6 instead of negative 5. I could have done negative 7 instead of negative 5 and would work. Okay. We're going to skip the warm-up. We're going to go right to activity 4.1. All right, so I'm pulling it up on my page here. So it says here, in a system of linear inequalities, the inequalities are known as constraints because the values of the expressions are constrained to lie within a certain region on the graph. Let's consider two trips that Chase guides determine whether each combination of rafters is a solution to the system of linear inequalities. Then describe the meaning of the solution in terms of this problem situation. So Chase is a river guide, it looks like. He does some rafting stuff. So A, first trip Chase guides 2 adults and 2 children. Second trip Chase guides 5 adults. So let's look at number 1A first before we go to 1B. So it's asking us to describe the meaning. Okay, so determine whether each combination of rafters is a solution of the system of linear inequalities. Okay. Let me just check to make sure. Oh, I'm sorry. We're going to do the get started because they do number 1 ties off of it. I'm sorry, guys. So that's what I was trying to figure out why it's not working. So it says a river runs through it. Chase is an experienced whitewater rafter who guides groups of adults and children out of the water for amazing adventures. The raft he uses can hold 800 pounds of weight. Any weight greater than 800 pounds can cause the raft to sink, hit more rocks, and or maneuver more slowly. Chase estimates that the weight of each adult is approximately 200 pounds and the weight of each child is approximately 100 pounds. Chase charges adults $75 and children $50 to ride down the river with him. His goal is to earn at least $150 each trip. Okay, so now just from there alone, we can pull out some numbers. By underline, actually, I'm not even going to underline. I'm going to highlight. So children are 50, adults 75, children weigh about 100, and adults weigh about 200. And his goal is 150 each trip. Okay? So the way we can write this. So weight inequality represent most weight Chase can carry in terms of raft. Okay, so weight. So we know an adult is 200 pounds. So we can write 200 and then put a symbol of A next to that for adults. Okay? We put plus, because we're going to add this together, 100 for children with a C, and his max weight is 800 pounds, as it said right up here. Okay? So there's our inequality right there. Actually, I shouldn't even put a equal, because it doesn't have to can be greater or less than or equal to. So he could carry 200 pounds is perfectly fine. Okay? So there's your answer for 1. That's for the weight. An inequality for the minimum amount of money Chase wants to collect each rafting trip. So he wants to collect minimally $150. So that's got to be less than or equal to 100, or greater than or equal to $150. Okay? So right there, we know that part there alone. Now, we know, let me just double check this. We know that Chase is an adult. Okay, so he earns $75 per adult. Okay, the problem is we can't say 75 times A because Chase is not paying. Okay, so Chase does not pay himself to do it. He's getting paid. So we have to take A minus 1 times 75 because that subtracts the total number of adults. So it could be 5 adults, including Chase. Now we really are only having 4 being paid, charging. Plus, children are charged $50, and obviously Chase is not a child, so we can just write that as 50 times C. Okay, that's how we do that problem there. Okay, so to rewrite these, we're just going to rewrite both of these together. So it's just going to be 200A, because this is right system linear, represent the max weight and minimum amount of money, so it's just pretty much doing the same thing, plus 100C is greater than, or I'm sorry, is less than or equal to 800, so it cannot be greater than 800 pounds. And then we said $75 for an adult, but we're going to take adults minus 1 because Chase has to be included in that, plus $50 per child, 50C, is greater than or equal to 150 because Chase wants to make, $150 per trip. So let's look back at this. So the first trip, Chase guides 2 adults and 2 children. Okay, so let's see if the weight works. Okay, so we said it was 200 times the number of adults. So there's 2 adults plus Chase, so that's 3 adults, plus 100 times 2 children. Okay, sorry guys. So now, we're looking at this. 2 times 3 gives us 600, or I'm sorry, 200 times 3 gives us 600, plus 100 times 2 gives us 200. So now that comes out to be 800. 800 is less than or equal to 800. So that works. So we can say this works for weight. Okay. Now let's check our money. Okay, let's see if this works out for our money. So if we look back at our formula for our money, we said our money was 75 times A, which there's 3 adults, minus 1, plus he charges the kids 50 times 2. Okay, so 3 minus 1 gives us 2. 75 times 2 gives us 150. And then 50 times 2 gives us 100. So this comes out to be $200 he earns. I'm sorry, 350. I'm sorry. I don't know where I was counting. So it comes out to be $350. So this also works for money. I'm just going to write works for, and I'm going to give the dollar sign. So the minimum weight or the max weight works and the money work. Okay. So now Chase is guiding 5 adults. So let's see if this works. Okay. This is going to be a little interesting. So let's see. So we take 200 because that's how much weight we're carrying times 5 adults plus Chase. That's going to be 6 plus 100 times there's 0 kids. And let's see what that comes out to be. Excuse me. 200 times 6 comes out to be 1,200 plus 100 times 0 gives us 0. So the weight is 1,200. It's got to be less than or equal to 800. So we know the weight does not work. So we can just say weight does not work. Okay, so problem 2, weight does not work. So weight does not work. He can't take it anyway. So we just know that does not work at all. So now they're asking us to graph the system of linear inequalities. Okay, so looking at this, we have to plug a few numbers in. Oops, sorry. We're going to plug a few numbers into this formula and kind of see how this works. So if we know that 3 adults and 2 children work. So first off, we can come to 3 right here and 2 and know that that's one of our points on the graph. Okay, we know that's going to work because we just did that up there. Let's see, we know we can take, if we're looking at this for children, if we say no adults, actually we have to include 1 adult for Chase. Sorry guys, I'm just checking the graph they give me and seeing how it looks. If no adults go at all, we know that max 800 pounds. If a child weighs 100 pounds, we can take 8 because 8 times 100 gives us that part right up there. Okay. If adults weigh 200 pounds, 200 times 4, because let's just say 4 adults, that gives us exactly at 800. Okay, so 4 adults is our max that we can take with 0 kids. So right there, there's a point. Okay. Where did they get that one from? They have, I'm just going to tell you guys up front, they have a point here. I'm trying to figure out where they got it. Where it'll be considered 7. So between the 6 and 8. And or 7. They have a point between 7 adults and negative 6 children, which I don't know where they're getting that, but they have 2 lines that come off from this. So they have one where it comes from 8 down here. And then they have another one that comes like that. I'm trying to figure out how they have that line. Because what they have is all this in here shaded. Oh. And obviously this goes up. They have all that shaded, and I'm trying to figure out how. Then I have this part here shaded one color too. I'm not entirely sure how they got that. But I know the first line that we did is correct because that's how we graphed out to see. So I'm wondering if they went lower on there. So just if your graph looks something like this, I'll leave this up here for a moment so you can kind of copy it. I will give you the credit this way. Okay. I'm just going to continue my lines here real quick. The best I can. Like I said, if it looks something like this, I'm okay with that. It doesn't have to be 100% perfect, just as long as it's close, and I will be okay with that. So I'll give you a moment to copy this all down, and then I will go on to the next part for today. A little bit more, and then we'll be done for today. All right, we're going to go on to the next part here. Let me just zoom out on my worksheet here. We'll probably finish this page and we'll call it a day. So it says the solutions of a system of linear inequalities is the intersection of the solutions to each inequality. Every point in this intersection region satisfies all inequalities in the system. Analyze your graph. Describe the possible number of solutions for a system of linear inequalities. So for this one, solution would be anything inside the two lines that are purple. So I would just say anything inside the two overlapping planes, meaning the purple area overlapping. All right. Give me a second, guys. All right. Looking at number B, is the intersection point a solution to this system of equalities? Why or why not? Like I said, that point of 7, negative 6 does not work. No, because you cannot have negative 6 children on the raft. Okay, so that can't be. Can't have a negative number. Identify 3 different solutions of the system of linear equalities you graphed. What does? Okay, skip that. We're not going to go sit through all those. Determine one combination of adults and children that is not a solution for the system of linear inequalities. Explain your reasoning. Okay, let's just say, for example, if we look at this, anything that's not in there, let's go this point right here, 2 adults, 1 children. Okay, so we look back, if we remember back to our formula of 200A, so A is the adults, so there's going to be 3 adults because you're including Chase, plus, we said 1 child. Let's see if that comes out to be less than or equal to 800. So 2 times 3 is 300. 200 times 3 gives us 600. 100 times 1 gives 100. So 600 plus 100 comes out to be 700 is less than or equal to 800, which works. Let's check our money aspect of it. So we said it was 75. A minus 1, so 3 minus 1, plus 100 times, or I'm sorry, not 100, 50 times 1 is greater than or equal to 150. Okay, so let's take a look and see. Give me a second just to get to where I need to be. Oh, I'm sorry. 2 adults is including Chase. So, we're going to believe this is 2 minus 1, 2. Gives our answer here a little different. So, I'm sorry, guys. We're going to look back at it. 200 times 2 is 400. 400 plus 100 is 500. So, that works. So, now let's look at this. 2 minus 1 gives us 1. So, that's 75 plus 50, which comes out to be 125, which is not greater than 150. So this does not work. We'll just say it does not meet money requirements. Okay, that's where we're going to stop today. We'll come back tomorrow and do activity 4.2. As a reminder, Friday there is no school. It is Good Friday. And I will talk to you guys soon. If you have any questions, please reach out to me via email. Thank you and have a great day.